Yeah, we'll give it a few seconds here. So, good morning to you guys, the people who are supposed to be online. It's all there. So, okay, good morning, New Yen. All right, let me double check a few things here. See where we're at as we double check a few things here. Let's take a look in our notes again. And see where we're at. We're in 262. Is that not it? Yeah. Online statistics transit. Integration by substitution we were working on. And let's take a look. So I think you guys are all here. So good morning to Nguyen. Let me get rid of this. Good morning to Jesus. We got Paula, Lele, and Arlene. Good morning to you guys, and good morning to everybody here. All right, so let me double check a few things here. So let's double check. Where we left off, I think I have some ideas. Let me get rid of this too. So we're going to work with some of these integrals here. We'll do some more. However, let's double check here. This is going to be of the form. If we go back, see if we can see this. Okay. Square root of a squared plus x squared. That's true. So, okay, we're going to use x is a tangent theta. Is that right? Secant squared. And it looks like we're okay, though. All right. Did you guys find an issue with this one by any chance? You guys working on this one? I don't know. We'll continue this one here. Remember this integral, natural log of secant plus what? Tangent, is that right? Plus c. So, I mean, assuming everything's okay with this, because I didn't get to double check everything yesterday. And here's where we're at. So we're going to finish that integral that we're looking at yesterday here, this quadratic integral, and try to go back to x here. Okay? It looked okay to me, but, you know, you never know. So now let's go back and look at this triangle here, right? Because remember, u is tangent theta here. So we're going to finish off this question that we were left off yesterday, or the prior day, right? It's in our notes. So when you say u is tangent theta now, that really means, I kind of look at it this way. Tangent theta is u over 1, right? And here's theta. Opposite, adjacent. What does Pythagorean theorem say? Right? This will be the square root of what? 1 plus u squared. Is that right? You guys okay with that? We're going back to that triangle here. So we integrated secant theta yesterday. And okay, now we're going to be able to find, we know what tangent is u, so this portion already is u, right? You guys remember this one from yesterday. Cosine, though. You say, what's cosine? It is adjacent over hypotenuse, and then you say secant is reciprocal. Square root of 1 plus u squared. All right, you guys okay with that one? Square root of 1 plus u squared. And then you might say, well, this is not x again, right? So u is going to be what here? X plus 1. So when you try to come back to finish this question here, u is x plus 1. And let me copy that. One plus what? X plus 1 squared plus x plus 1. Double check. So anyway, double check that we were okay with this one. I think we're fine. Nobody's able to find the error. And so I think we're pretty good. But anyway, I think I have a couple of more trigonometric integrals I want to kind of look at as some examples. I don't think we did this one here. So I want to be able to do some, show you guys some examples from trig integrals and quadratic and form, or these quadratic integrals. So I'm going to kind of give you guys a little warm up here, or an example here. Maybe you guys want to try something like this for yourself. Okay? So let's try this here. Square root 1 minus 16x squared dx. See how you guys handle that one. I don't think we did this one, right? This doesn't look familiar. See in your notes. Double check. And maybe something like this as well. Number 2, integral 1 over 4x squared plus 9 squared dx. Yeah, we'll try a couple of these here. And I'll give you guys some time to try it yourself, right? So we can all wake up and get warm. See how long this takes here. We'll give you guys some time. And we'll get nice and warm. How many people are done with number 1? Okay, you guys want some more time? Nope. All right, no more time. Okay. All right, let's kind of get warm with this here. All right, so when you first see this kind of question here, right? And they're similar in nature. This is why I wanted to do this, because if you look at the book and you try to do some of those questions, you go, wait a minute, there's something like this here. What happened, right? So what do you guys think you want to do with this portion here? All right, what do you guys think would be a good idea? We've seen something in the last example, because with some of these questions, these are where you start with a U sub. Okay? And so that was my idea there. I said, okay, let's go over some of these examples where you maybe start with U sub, right? And so take a look at this. This is 4x squared. Is that right? All right, you guys okay with that one? And so if that's the case, this is my U. So you want to start by saying let U be what? 4x. Okay? So what that gives you is 1 over the square root of 1 minus U squared. Now, what's going to be here, you say du dx is what value? That's going to be a 4. So dx becomes du over what? 4. So this portion, du over 4. Now, pull out your constant. What's the constant? Yeah, so you're going to integrate now 1 over the square root of 1 minus u squared du. So now, ladies and gentlemen, take a look at this here. So that was kind of like I said this morning, I wanted to take a step back and not jump into the quadratic integrals just yet, because I wanted to share with you guys some of these other kind of integrals that pop up, where you have to do a u sub first. And it's going to be also something that you do over here in this next one too, right? And because you might say, I won't do that yet, but, well, maybe I'll start to do that, right? Why do I say maybe this is a u sub as well to start? Right? Look at it this way. You see the 4x squared? You see the 9, okay? I can do the same kind of thing here. I can replace this here with 2x to the what? Second power. And I can replace this with, really, this is like a 3 squared, so I just want to kind of point that out. Right? So if I start now again here to call this my u here, so if I let u be 2x here, and we say du dx is 2, and then that means my dx is going to be du over 2. So notice what happens here. We'll get, this is now going to be u squared, right? And you can still say u squared plus 9, but u squared plus 9 squared, and that'll be du over 2. So we'll keep it that way. And so we get to pull out the 1/2 now. So you could say, okay, here's my 1/2. So you have the integral here of 1 over u squared plus 9 squared du. So similarly, they start off the same exact way, right? Okay, you guys with me on that one? They start off the same way. So I kind of want to compare and contrast. Yeah, did I screw up there? Oh, square root. No, there's no 1. I'm thinking of the last one. Good. Okay, I did screw up. Thank you. Let's get more coffee. Coffee, coffee, coffee. Thank you guys for noticing that. Okay. So let's just emphasize we have constants here. There's a 4 and there's a 2. Good job. Okay, you guys. Right, you guys see my point here, how you maybe want to start it off with that u? You guys see how that works? Okay. So now let's focus on this integral, right? And you go, okay, what case is this here? So we want to look back at our cases. And if I look back at the cases, we go, oh, what case is this going to be? What do you guys think? Right? Let's double check. Case 1, case 2, case 3. It's going to be the case where you have a squared minus what? X squared. Is that right? All right. So you go, okay, what case is that? We can try to balance everything. What case is that? I think we can say that's case number what? 1. And if it's case 1, it's not X now. Let's be careful here, right? Case 1, you're going to say not X, because the variable here is now U. So make sure it's U, and A is 1. Is that true? So say U sine theta. All right. So it's really sine theta for U, right? Okay, after that, what's that going to be? What's the derivative of sine? Cosine. So I say, okay, cosine. And then if you guys remember, you can replace that radical of 1 minus u squared. What do you replace that radical with? Do you guys remember? It's going to be a something. A is 1. Is it? Remember that radical we did? You guys remember that? So you might want to put that in your notes too. Is it sine theta or cosine theta? I think it's cosine theta, right? Do you guys remember what I'm talking about? So that square root of 1 minus u squared, if you plug in 1 minus, if u is sine theta, that's 1 minus sine squared theta. And then 1 minus sine squared theta is cosine squared theta. You guys remember that? So this is what I'm saying. I think right off the bat, what you guys really want to know how to do is get these things, your u, your du, and your radical. That's how I organize that in my notes, the u, du, and the radical here. So at this point, with this detail, 1/4 now the integral, the radical is just cosine theta. And then du is another cosine theta, d theta. So, ladies and gentlemen, this is 1/4 cosine squared theta d theta. And then again, I guess I'll just keep the same color here, right? You want to know how to integrate cosine squared, theta. So again, it comes down to you knowing how to do a trigonometric integral, right? A trig integral. And this is like the basis of a lot of, stuff we'll study in the future. Let's see. Got it, Jesus. Thank you so much for noticing. Yeah, we had a good, I don't know if you guys were watching that thing yesterday, but it was a good day. We had some good progress. We're going to continue with some progress on those issues of AB 1705 and continue with that progress, but had a good day. All right, what about cosine squared? What do you replace that with? Do you guys remember? That double angle identity? 1/2, what is this? Sorry, I'm going to give the answer. 1/2 1, is it plus or minus? Cosine 2 theta. Remember that, double angle? Is it plus or minus for cosine? Plus? All right. And then, so, every detail, if you guys want to see that, here's what I want to remark about this. Pull out that constant, that's going to be a 1/8. And again, technically, to integrate the rest, you would do u sub, right? So I'll just kind of integrate that for you guys, and that'll be a 1/2 sine 2 theta. And I have to now think. What do I think of? I'm going to think about something. I think about, what do I think of? Derivative of sine is cosine, so that's going to be plus. Okay, so we end up with 1/8 theta plus 1/16 sine 2 theta. Something like that. You guys okay with that one? Now, that's not your answer. You say, why is that not the answer? Do you guys remember what you have to do with a couple of these here? We got to go back now, right? This is theta. What was u? U was sine theta. So now we have to write this integral in terms of u now, right? So u is sine theta. So I have to convert back to u. And logically, I go back to the statement u is sine theta, which means sine theta would be u over 1. So when I draw my triangle here, theta, right? What's the definition of sine again? It is opposite over what? Hypotenuse. And this is always going to be that radical. Right? So the radical is what? Yeah, square root of 1 minus u squared. You just use Pythagorean theorem. You can find that. It's going to be the radical. Now, you might look back at this and you say, well, okay, well, how do I really use this information, right? So go back up here because you got sine 2 theta. Remember this double theta? This angle's theta. It's not 2 theta. So what's the identity you guys always use to convert sine 2 theta? It's going to show up. Sine 2 theta, what's that identity again? It's 2 what? Sine theta, cosine theta. This is a big identity, I would say to you. If you're going to get a tattoo this weekend, that might be one to get, right? Sine 2 theta is 2 sine theta, cosine theta. Now it's a single angle. So this is now going to be 1/8 theta, right? Plus 1/8 sine theta, cosine theta. And you already have sine theta. This one's going to be u. And what is this? Isn't this inverse sine of u? You guys with me on that one for theta? Because remember how they define it? They define it here. If u is sine theta, I can get the inverse. They define it so sine theta is 1 to 1. So you have an inverse sine. So, okay. And now we just need cosine, right? So the definition of cosine, though, is adjacent. The adjacent side over the hypotenuse. So here's going to be square root of 1 minus u squared. So final answer here. 1/8 inverse sine u plus 1/8 u square root of 1 minus u squared plus c. All right, you guys okay with that? Looks like it's okay to me. You guys see anything that you find any errors maybe? You guys okay with that? What's the last substitution now? All right, this is u, isn't that right? So we have to find out what u is now. So you go, okay, what is u? So the other u is going to be 4x. So you say, okay, that's 4x. So replace this with a 4x. Anyway. right, ladies and gentlemen, do you guys find that there? So this is a full illustration of where you start off with U sub. Some of those questions are there. This is the other U sub question, right? So if we say, let's go look at this one. Maybe I want to copy it now and pull it down or something. If I can. All right, so here's where we started the second one. We originally wanted to do the U sub in the beginning, compare and contrast here, right? So we compare and contrast. So you look at this situation, and we have to find which trig substitution, which case this is, right? And I'm going to point out to you, there's no radical here. So this is kind of, we're transitioning a little bit. Because you say, Mr. Judge, aren't you supposed to have the square root of like an x squared plus an a squared here, right? Because you gave me some of these worksheets, and you go, oh, where's the radical? Okay, so we're transitioning a little bit to the quadratic integrals. So it's a little transition here. And I'll say, well, the radical isn't there. And you might say, okay, then what do? You still could do a trig sub, ironically. So even though the radical is not there, do you see a case we can use? I think that's case 2, is that right? If you did have a radical, that would be case 2. What does case 2 say? X is a what? A tangent theta. Is that true? All right, you guys okay with that? So this number, though, is a 9 here. So because that's a 9, what do we use for x? 9 is what? 3 squared. That's your a value, right? So that'll be 3 what? Tangent theta. So even though here, it's really kind of like a quadratic integral as well. You know, because they don't have the radical, you can kind of think of it that way, quadratic integral. And if x is 3 tangent theta, what do we have here? What's the derivative of tangent? Ain't that secant squared? Okay, you guys see how that works? Derivative of tangent is secant squared. So you have 1/2 the integral now, 1 over, now I'm going to put we got to say a u, that was an x. Got to change this all to u. So that would be a u now, remember, because they changed the variable there. This was u and du. So when I put 3 tangent, what do you do there now? Square that. So I'm going to show you guys this here. This is 9. I'm going to put this all together this way here. And that'll be 3 now, secant squared theta d theta. Okay? So double check all of that. Right? So it's u, and there is no radical, but that's fine. It's still going to be a case 2 kind of ish. And let's see what we have here, because we have to do a little bit of that algebra, right? 1 over, this is 9 tangent squared theta, plus 9, right? Squared 3 secant squared theta d theta, okay? And I think I'm going to do something here. I'm going to pull this constant out, okay? So I really have 3 halves here. And let me just put it over here to begin with. So there's the 3 halves there, okay? And what do you guys think you could do down here? Anybody have any idea? What do you think we do with this 9 tangent squared plus 9? Yeah, we're going to factor. We're going to do some algebra, right? That's really 9 what? Tangent squared theta plus 1. And what is tangent squared theta, by the way? That's secant squared theta, right? Okay. Three halves, integral, 1 over, let's put it all together. Don't forget there was a what here? There's a 9, is that true? Okay, so what is that going to, so you say, what's in between here? Just so you guys don't lose sight of this, right? What you have there is 9 secant squared theta, but that whole thing is squared, and you have another factor of secant squared theta here, d theta. So the denominator we handled, and so that's a 3/2 now, integral 1 over 81 secant to the 4th secant squared. And that'll be 3 over 2 times 81. Bring that out. And you really have 1 over secant what? Squared theta. And I think we could simplify 3 and 81 here, right? How many times does 3 go into 81? 27 times, I think. Double check, I haven't finished my coffee. In fact, I've barely started. And the reciprocal of secant squared is what? Cosine squared. Okay, you guys okay with that one? See my point? Notice again, you say, what do we end up with all of these substitutions? This is a trigonometric integral. So really that last section on integration is important, right? You guys think? Pretty good, pretty big? You might say, yeah, because everything comes down to a trig integral. And then the identity, remember the identity is 1/2 1 plus cosine what? 2 theta. And all together, I'm going to do this. Well, okay, maybe I shouldn't skip that. Because sometimes people will say, where did you get that constant, right? I'm going to put it here. And so it comes down to another particular integral. And then I'm going to get 1 over 108 integral 1 plus cosine 2 theta what? D theta. Right? Because I pulled out that 1/2. So you get that 108 now, theta plus 1/2 sine 2 theta. And then I'm going to multiply, distribute 108 theta plus 1 over 216 sine 2 theta. And there's a plus c, so let's put our plus c. So trig substitution here now. All right, so remember this deal here. We have to now write this in terms of, where was our u again? U is right in here. 3 tangent theta, right? So u is 3 tangent theta. We have to put this in terms of u. So since u is 3 tangent theta, remember that means by definition, tangent theta will be u over 3. And then you get to what? Bring out your right triangle. Definition of tangent, opposite over adjacent. And then Pythagorean theorem, u squared plus 9. So let me remind you guys again here. Remember I just said to you guys, if you're going to get a tattoo this weekend, what's a good one? Sine 2 theta. This one pops up all the time, math and science. Sine 2 theta. It's like, it's amazing to me. You know, I used to look at that and go, my God, sine 2 theta, sine 2 theta? 2 sine theta what? Cosine theta. Okay, so I'm going to say, here's the factor of 216. And let's put the 2 sine theta, cosine theta. So yeah, some of these things show up over and over again, which is a good thing, you know. It's good because I think what it does for you, it helps reinforce what you're doing. And, all right, so, okay, notice a few things here, right? Since tangent theta is u over 3, what does that mean about theta here, right? See, here's theta, here's theta. They define it so that it's going to be invertible. So in other words, you have the inverse here. So this is going to be inverse tangent of u over 3 for your theta. And then sine theta, we're going to have to get sine theta and cosine theta now. Sine definition is opposite over hypotenuse. Cosine definition is going to be adjacent over hypotenuse. Is that right? And since I'm dealing with this 2 and the 216, let me share this with you guys. This would be a 108, right? So I'm going to write it down this way so far. I'm going to say the factor 1 over 108 inverse tangent u over 3. Looks like, again, plus 1 over 108. Okay, sine now, u over square root, u squared plus 9. Cosine, 3 over square root, u squared plus 9 plus that constant. So you have the factor, again, 108 inverse tangent, and then plus, oh, and then you have, this will be 3u over simply u squared plus 9 plus c. Now 3 goes into 108 how many times? 3 and 18, is that 36? Double check, because I'm not awake yet. I think I'm okay. All right, you guys okay with that one? One over 108 inverse tangent u over 3 plus 1 over 36 u over u squared plus 9 plus that constant here. You know. So double check, ladies and gentlemen. Double check on this one. Does it look like we're okay with that one? Square, square root? Okay. Now what is u? Go back all the way to the beginning. What is u here? Say u is going to be 2x. Is that right? So u is 2x. Okay. 2x. So wherever there's a u, replace it with a 2x. 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 So double check. 108 inverse tangent 2x over 3, 1 over 36 times 2x, and down here it'll be 4x squared plus that 9 plus c. So let's clean this up. You see this 2? This will be what? 18. Okay? So we get 1 over 108 inverse tangent 2x over 3 plus, looks like it's 1 over 18 x over 4x squared plus 9 plus my c. So ladies and gentlemen, here we go. You know, that's kind of what I wanted to go over a bit today, and there it is. Right, so as you guys can see, there's a theme today. The theme is using that u sub before you do a trig integral. So that's the theme of the day, using u sub before we use a trig integral. And also, you don't even have to have a radical to use this trig substitution, as we've seen here. So let's give you guys a good one here, in a sense. I don't want to say a good one, but let's give you guys one here. Yeah, let's give you guys a good one. You want to take a little breather here? You go, wait a minute. Integral. So remember the other day, you don't even have to have a radical to use this trig substitution. So I'm going to give you guys another example here. It's a trig substitution because it's a trig sub. They call that also a quadratic integral. It's going to be using the tools we just talked about yesterday and today. So notice this here. This is a what? Isn't that a quadratic? Okay. So they call it a quadratic integral. So what do we do with this? What do you guys think? What did we do last time with this portion? What do you guys always want to do? You have to do a complete the what? You want to complete the square with that quadratic here. Okay? Because what I'm going to show you guys here, this integral by completing the square is going to be the same as 9 minus x minus 2 squared dx. Okay? In other words, that term, that quadratic, is what you guys see here. So you're going to have to go back to that complete the square process. Now, I have that on my intermediate algebra portion, completing the square here. So let me share with you guys here the algebra behind that complete the square. Remember, you start with this, right? You start with what we have here. 5, what is this? Plus 4x minus x squared. That's under the radical. We have to complete that square. So I would say, you know what I do is I write it in the form of a quadratic here. Okay? And if you guys remember the process of completing the square, right? You have this term here. This term needs to be 1 because that's like an ax squared plus bx plus c. We need that to be a 1. And so what you can do is you can factor that number out, that negative 1, and you're left now with x squared minus 4x minus 5 here. Okay? Because right here, to complete the square has to be a 1, a positive 1. So what I'm saying now is you are free to use your algorithm here. You can complete the square now with what you see right in here. Okay, so remember the process for completing the square now? What do you guys do with that? Remember this? You start with this b. So the first step would be negative 4 over 2, which is going to be what? Negative 2. And then you take that negative 2, you square it to get positive 4. So you're getting this number here, and you're getting this number here. Okay, you're getting those two values here. Okay, so remember, we're doing the orange part. This is the part in orange, right? You get x squared minus 4x minus 5. Now that's going to be, we're doing the orange part. That orange part, x squared minus 4x, you add 4, subtract 4, and then you subtract 5 here. All right? Okay, and so let me go back and remind you guys what you do. Use that value. And if you guys remember, what do you guys do with this portion here? Because we're running out of colors. You're supposed to factor that portion, right? And then this last two, you're only supposed to add. So you factor and you add here. So at this point here, if you remember in completing the square, you don't really even factor, right? The add portion is -9. So you don't really factor. You always use the value found in step 1. I mean, if you factored, it will be x minus 2 squared times x minus 2. Or x minus 2 times x minus 2, which is x minus 2 in parentheses squared. So this is all about completing the square here, ladies and gentlemen. And this is the portion in orange here. So the general rule of thumb when they give you these quadratic integrals is you complete the square. Now, don't forget you have that -1 factor here. You go, oh, what does -1 do when you multiply to all that? You know what it does? It changes the signs. So this is now minus, and this is now what? Plus. But I happen to write it this way. I put the 9 first, x minus 2 squared. Okay? Because I applied that factor of -1 now. And isn't that what I claimed we'd get here? When I said when you complete the square, you're going to get this integral, right? So that's what I'm saying here. We're going to get this integral. And you start by completing that square here now. So, okay. So we set that table here. And then now you guys can see from here, you go, oh yeah, this is now like the stuff we started with this morning, right? That's my u. U is x minus 2. du is dx. So this is going to be an integral of square root 9 minus u squared du. Okay, so that's just like now what we did. So now when you go, okay, what case is this? You guys remember what case? Yeah, you want to look for, let me go through the same. This is a trig sub. So you do a u sub and then a trig sub. So we're going to say, okay, this is case. It has to be of the form a squared minus x squared. Let's not forget, it's not going to be an x, it's going to be a u, right? Okay, so we have to look at our cases now. So go back and look at the cases now. Oh, this is case what? Case 1. Okay, good. All right, what do we use? I can't see that there. Case 1. Is that a sine theta? What is a? 3. And oh, I did it again. Not x. U is it u is 3 sine theta? You guys okay with that? Du is 3. Derivative of sine is cosine theta. That'll be a d theta. Replace the radical is going to be 3 cosine theta. Is that true? Double check because I'm not awake. Right? You guys set that up right? You guys remember I'm saying you set it up? I think that's what it is. So the integral becomes, well, it's no more radical. It's going to be 3 cosine theta times, what is du? Another 3 what? Cosine theta d theta. So that's going to be 9 cosine squared. Half angle identity. How many times have we seen that one this morning? Isn't that crazy how you see a lot of them over and over again? It's like we've seen this integral. Jeez. You know? So that's why sometimes it's good to know about. So I'm going to save some time, pull out that constant now. Do you guys know what I'm saying? That's why I kind of write it under there and I can pull out that constant 1/2. Anyway. 9/2, let's go. Theta plus 1/2 sine 2 theta. Right? Anyway. All right, so distribute here. You got 9/2 theta plus now 9/4 sine 2 theta plus c. And I'm going to do this from the beginning because you go, I think I've seen this how many times today. Sine 2 theta is 2 sine theta cosine theta. We know we're going to have to convert that anyway, right? That gives me 9/2 theta plus 9/2 sine what theta cosine theta. Right? Right, so here we are again in terms of theta. So what happens now? Let's go back here. You say, what happens now with this? What was, what is u again? U is 3 sine theta? Right? U is 3 sine theta. So since u is 3 sine theta, we're going to have to do this again. Right? And so from this, let's do all the analysis here. Theta will be inverse sine, by the way, right? That's one thing we know. And sine theta. Okay, sine, that's going to be opposite over hypotenuse. And this is going to be 9 minus u squared, I believe, right? By Pythagorean theorem. So remember, we need a sine theta. Oh, we got a sine theta. We need a cosine theta. Cosine adjacent over hypotenuse. So we need this. That goes here. We need a sine theta. Goes here. We need a cosine theta. Goes here. Nine halves. So 9/2 theta inverse sine u over 3 plus 9/2 sine theta is u over 3, and then cosine theta will be square root of 9 minus u squared over 3 here. Okay, plus c. 9/2 inverse sine u over 3 plus that 1/2 u square root of 9 minus u squared plus that c. Okay? All right, what is u, ladies and gentlemen? We got to get another u, is that right? U, yeah, we got to go x minus 2, right? Way back here. X minus 2 for the u. So we got to put it all in terms of x. So wherever there's a u, x minus 2. X minus 2 right in here. X minus 2. Now, you could leave it like this, by the way. Let me little bit OCD. Let's put our final answer in black. So you could leave it like this if you like. I'll put x minus 2 over square. Here's my point. This will be fine, but let me remind you guys in the first place, what was this to start with? Because sometimes when I write the answer, yeah, you might look in back of the book and you might see that radical to begin with. Remember that radical? What was 9 minus x? Remember this one? Go out there with the original question. Yeah, right here. This was that 5 plus 4x minus 4x squared. 5 plus 4x minus 4x squared. So you might see 5 plus 4x minus 4x squared. That's what I'm saying. 5 plus 4x minus, was that x squared? Yeah. Here's my point, because remember, you completed the square there. Remember that? And those quadratics are equivalent. So either way would be fine. In all honesty, either approach is good for you. You know, so I'll see it that way. But anyway, and double check, is that 1/2 going to be there? I guess so. Anyway, whatever. Yeah. Let me just see what I have here. Is there anything else that's interesting here? These quadratics. I guess it's here. Should we try one more? What do you guys think? Should we try some more quadratic integrals? You ready for a break, or have you guys try one for fun? Have you guys try one? It's going to look similar. Square root of x, or integrate x over square root of 5 plus 12x minus 9x squared. Okay, let's get out the clock here. Give you guys some time. All right, should we go over this after the break? Let's take a break. Okay. We earned a break. Maybe we'll go to, where? House of Pancakes. Huh? There's a little kink in this one, I think, if I remember. But it's always good to kind of get students, I should say, their juices flowing, you know what I mean? Get them to kind of think. Okay, we'll take a break. We'll be right back. Bread. Not break, but bread. All right. Okay, ladies and gentlemen, let's try this one out here, right? There's a little bit of something going on here that's kind of interesting. Is that right? So just to kind of go and remember here, this is a quadratic integral. And there you have a complete the square kind of issue, right? So you want to start here by completing the square. So anyway, okay. We're going to approach it the same way we approached the other question, right? So I'm going to just rearrange the terms. I'm going to factor out the -9. And then you might say, well, what happens when I factor out that -9 here, right? What do you get now? So it's negative 12x over 9. Looks like minus 5/9. Okay, double check here. It'll be x squared minus 4. 3 goes into 12 4 times, so it'll be 4x over 3, right? Minus 5 over 9. Anyway. So we're going to have to complete the square. So now we really complete the square here if I try to get another color with this. This is the idea. Okay, do you guys remember that here? So here's where probably there's kind of an issue here. And it's not really an issue. It's just working with some fractions, right? So now you might say, oh, okay, is that kind of the wrinkle? That's kind of the wrinkle here. So remember, you take that fraction, you divide by 2. And so that's really -4/3 times 1/2, which is actually -2/3. So double check, ladies and gentlemen, that's my first portion. And then step 2, -2/3 squared, we know is positive 4/9 here. So the third step is what we call, or what I call the rewrite step, or just simply you're adding that 4/9, you're subtracting that 4/9. Don't forget you already had here minus that 5/9. So for complete the square, that number in step 2 goes there. And then if you guys remember here, in complete the square, you're supposed to factor right here, is that right? But don't really factor. And here you're supposed to add. But don't really what? Well, you're going to add, okay? So here's what I want to remark here, right? So when complete the square, you always put the value found in step number 1. -2/3. And double check, what's this going to, is this going to be -9/9? Is this going to be -1? Is that true? Did you guys get that when you completed the square? I don't know. So this is the orange portion here, or not the orange, sorry, the green portion. So now if you said, but you had already that -9 factor, right? So what does that do for you? Multiply -9 there. You're going to distribute that negative, so it's -9 x minus 2/3 squared plus 9. Is that right? And then I write it this way, 9 minus 9 x minus 2/3 squared. All right. And you say that goes under my what? That's the orange portion here. And I might even factor out the 9 here. You get 1 minus x minus 2/3 squared. So this is now the orange portion that goes under the radical here. Okay? So that was just the first part of completing the square here. So, okay, so that means I have an integral here of x square root 1 minus x minus 2/3 squared. Okay, double check. That's what I'm saying here. This is my orange portion here. And you're gonna take the square root of the product. In other words, you're gonna get what? 1/3 integral x over square root, ladies and gentlemen, 1 minus what? X minus 2/3 squared dx. So double check, ladies and gentlemen, that everything's okay here. All right, double check that. So at this point now, remember, what do you think you're going to do now with this? What did we do before? What are we going to let u be here? So you get u be what? X minus 2/3. Is that right? And so what does that give you? Is that du is dx? So this is your u. This is your u sub 1/3 integral x over square root 1 minus u squared, and then this is du, ladies and gentlemen. Okay, you guys okay with that one? Now, what's the problem here, though? Isn't there an x there? You go, what do I do with this x? Right? You're going to replace it with, what is that? You know, you go back up here and you say, but u is going to be, if u here, right? What do we know about u? Is x minus 2/3. What does that mean about x? X will be u plus what? 2/3. Is that right? So this will be u plus what? 2/3. So ladies and gentlemen, okay, so isn't that what you're going to get here with this? Now you might say, what should we do with this here? Well, there's a couple of things I think you can do. So note something here. I got this 1/3. Properties of integrals. Isn't this going to be u over square root 1 minus u squared du plus the integral of what? 2/3 over square root 1 minus u squared du. And I think we want to put a bracket here. So if you said, did you just split up that integral because the integral of a sum is sum of integrals? And I'll say, yes, I did. And then you might even say, this is going to be 1/3 integral u over the square root 1 minus u squared du plus, pull out that factor, square root 1 minus u squared du. So let me remind you guys here, take a look. Here and here. What do you guys know about this? We have two integrals to perform. Is that right? Now you can do u substitution, but is there anything, does anybody know anything about this one here on the right side? Do you recognize that? Is there anything that we know? Is that an integral that we know about? Huh? I'm just curious. So I'm going to say this. Is this a known integral? I don't know. I'm going to have to go back to, maybe I know it, maybe I don't. I'm going to have to go back to the what? Let me see if I can find all that stuff. All right, so is it a known integral? In other words, we can actually do a u sub if you guys want to do a u sub. Because it looks like for a u sub, isn't it going to be of the form a squared minus x squared, where u is a sine theta? Do you guys know what I'm talking about? If we did it, sorry, not a u sub, a trig sub. But what I'm going to do here is I'm going to go back a bit, and I'm going to say, let me try to do this here. No, I guess it's not here. I guess it's over here. 262. And if 262, do you have a formula sheet? Okay. Wait a minute. Wait a minute. Isn't it right in front of me? You guys know what I'm talking about? Oh, this is inverse sine of u. Is that true? Maybe we got to scroll right in. Here's what I'm saying to you guys here. Maybe you guys don't see it here. Let me do this. There we go. U sub. That's inverse sine of u, I think. Nice. All right. So since we know that, you guys think we should use that? What do you guys think? I would say absolutely, ladies and gentlemen. We know that integral. Okay, you guys okay with that one? All right, now you might say, okay, what was this case here if we go back there? So it pays to know some of these kind of things, some of these integrals, and we go back to the cases again. You go, oh, this is a squared minus x squared square root. Okay, we use u is a sine theta. So I'll say u is sine theta. What's the derivative of sine? Cosine theta d theta. What do I replace the radical with? 1 minus u squared. You guys know? That's like saying, sorry, you guys can't see that. I'm writing it down. Okay? U is sine theta. 1 minus sine, that's going to be cosine theta. Is that right? Okay, you guys know what I'm saying there? So let me just actually just kind of highlight this because I already integrated this one. And over here, let's try to integrate. I'll keep it in red. U sine theta over the radical cosine theta. And what is du? Cosine theta d theta? Is that right? Double check. So it looks like this is the integral of sine theta. Okay, is that right? You guys double check. You got sine theta on top. Cosine theta, cosine theta. So that looks, what's the integral of sine theta? See, derivative of cosine is minus sine. So this would be minus what? Minus cosine theta. Good. Okay. Don't forget your constant. Don't forget your constant here. So let's see what we have here. And I apologize, that shouldn't be, oh yeah, that is, oops. Let me apologize here, we're not ready yet. Let's double check. This is going to be minus cosine theta, okay? And it's going to be plus a constant. So what do we have to do again? I'm going to change the color. You have to convert that to u. Is that right? Okay, so you're going to now say u is sine theta. Got to convert that to u. Sine theta would be u over 1. So here's your triangle, your right triangle. It's definition, opposite, square root. Okay. So cosine theta, what is cosine theta? Adjacent over hypotenuse. Okay. Now we're ready, ladies and gentlemen. Now we're ready. Here's what we're ready for. This integral is what? Square root of 1 minus u squared over 1, just the square root of 1 minus u squared. So we have integrals in terms of u now. So let's write that down. Minus square root 1 minus u squared, right? And then it's going to be plus, or let's be careful. Don't forget the constants. 1/3. 1/3. And then the other one is plus 2/9. And that was the inverse sine now of u plus the constant there. 2/9. Okay. So we have to remember now, what is u to begin with? What was u, ladies and gentlemen? I think it was, is it x minus 2/3? Yeah. So replace that with an x minus 2/3. Plus c. And, you know, you can write this as your answer, but remember what I did earlier today here, right? You might look in back of the book, and instead of 1 minus x, you know, minus 2/3 to the second power, what was the original radical to begin with? Yeah, you might say 5 plus 12x minus what? 9x squared kind of thing, you know. I mean, you don't have to put it that way. Plus 2/9 inverse sine x minus 2/3 plus that constant. So ladies and gentlemen, here you go. You know, here's that final answer with a little bit of a kink, and sometimes they show up. You know, sometimes they show up in your questions here. There's some more I can do. Should we try something like that? It's very similar. What's our timeline? We've got about 30 minutes left. Yeah, I mean, if we tried that one. Actually, it's probably a good idea. Here's what's a good idea to do. I know what I'm going to do. Instead of doing something very similar. Yeah, here's what I'm going to do here. Okay. All right, good job. Okay, so I put some of those notes back away, and there you guys go. I want you guys to recall something here. This is from Math 260 here, right? What we're going to start to introduce and do is more integration, But I want you guys to recall a process called partial fraction. Do you guys remember what this was? Decomposition. And you go, what's partial fraction decomposition? This is from Math 260, pre-calculus, right? So in general, here's what partial fraction decomposition is. You have a ratio, you have a fraction. We start with a rational function here, by the way. So let's lay some groundwork here. Do you guys want to know what's a rational function? It's another function known, this is r of x, right? It's a quotient of two polynomial functions, right? R of x, where p and q are polynomials. So what's a polynomial? Do you guys remember? Strict definition of a polynomial. This is a rational function. Okay. Do you guys know what a polynomial function is? I'll give you a definition of polynomial. Yeah, you've seen them. You guys know what these are. Polynomial function, and I could use the letter P if you want to use P, but anyway. P of x is an x to the n plus an xn minus 1 all the way down to a1x plus a naught, okay? Where your an minus 1, a1 and a naught, these are constants. Okay, so let me kind of emphasize those. These numbers are constants, right? This is your polynomial function. This is the formal definition. N is the degree of the polynomial, and it decreases down to 1 and 0. But anyway, a1x. It's really a1x to the first power, but we never put it there. A naught plus a naught. So this is a formal definition of a polynomial. So we always want to start off by giving you that at least. And all of these are, these things are constants, right? So that's just the formal definition. X is your variable, and the degree of the polynomial is n, the highest power. So you've seen a bunch of polynomials in your life, right? But for example, they're going to ask you to start to integrate, right? These functions. You're going to integrate rational functions here. And for example, the first kind of example you guys want to do here, or they always start that first example in the book, something like this. You have like, what do we have? Maybe x squared plus 2x plus 1 over x minus 3 dx. So in general, we're going to start to look at integrating these rational functions. You go, well, how do you integrate a rational function? For the first step, you guys want to note this scenario. The degree of the numerator, because remember, you have polynomial on top, polynomial on bottom, okay? If the degree of the polynomial in the numerator is bigger than the degree of the polynomial of the denominator, here's what you simply do. You use algebra. All right, so right in here, again, that dreaded word, use algebra. Okay? So what am I talking about when I say use algebra? It's actually beginning algebra, ladies and gentlemen. We're going to have to go back and remember some beginning algebra. What I used to say when we used to teach beginning algebra in the school, I used to tell students, okay, contact your younger brothers and sisters who are taking beginning algebra and have them tutor you, you know. And that was just code for remember some beginning algebra, right? So in other words, do you guys remember how to do any of this in beginning algebra? What do I mean by that? What I mean, do you remember how to divide, right? Because if this was nice and factorable, the numerator, you just simplify your fraction. But it's not, you know, or even if it is factorable, it's not factorable in a way that you can simplify, right? So what I'm saying is, remember that technique in beginning algebra called division? I actually have it on my website. This long division, you know, from beginning algebra. So, you know, you start off, your first type of questions of rational functions are these types. You know, because they introduce this idea to you and they go, oh, do you guys remember how to divide? You guys remember the process? Right? It's a 4-step process. Let me get some colors. You take this first term divided by this term, right? So it's x squared divided by x. So if this was beginning algebra, I'll tell those students x squared divided by x is x. That's a quotient. Where do you put that? Above the term, the x term, the linear term. Okay, and then now step 2, remember what step 2 is. You take x and you multiply it times x minus 3. You get x squared minus 3x. So that goes down here, if you guys remember the division algorithm. Step 3 is a subtraction step. So subtract and add. What do you end up getting? 5x. Bring down the 1. And what do you do now? If you guys remember, you repeat the what? Process. So you say, what's repeating the process? Well, step 1 again. 5x divided by x is going to be what? 5. That's positive. It goes above the constant term because it's a constant. So you place it above that constant term. This is your new step 1. You know, step 2 is 5 times x minus 3, which gives you 5x minus 15. Is that right? Step 3, you subtract. You get that 16. Okay? Now you're done. So here's the point. Here's something that I want people to remember here, right? What are you really looking at now? Okay? We have to put it all together. This is completely analogous to writing an improper fraction as a mixed number. So here's the quotient. Here's the remainder. This is what's doing the dividing. So you're writing your question as the following here, okay? Quotient, remainder, divisor there. So this is the long division from beginning algebra. So this integral is really going to be now, what was the quotient? X plus 5, okay? What's the remainder? 16. What were you dividing by? X minus 3. You guys okay with that? I'm going to bring this down, though. Okay, and remember what this really meant. This is a mixed number, so you write it as a whole portion plus your fraction. That's addition here. So here's what you get. X plus 5 plus 16 over x minus 3. Okay, so here's kind of the first class of questions that they want you to do here. And then you might say, well, how do I do this? Remember properties of integrals. This is the integral of x plus 5 dx plus, pull out your constant, 1 over x minus 3 dx. Okay, so here's again that quotient, remainder, divisor. And so now you have two integrals you guys can integrate. There's two now. So how do you integrate this first part, right? You go, okay, this is going to be what? 1/2 x squared plus 5x plus 16. How do you integrate this? This is going to be, remember this u sub. Yeah, natural log, outstanding. So it's going to come out to natural log absolute value of u, which is x minus 3, plus that c, and you could leave the c at the end. So the point I'm making is you can integrate that rational function. So we're going to focus on integrating rational functions, fraction functions. Okay, now remember the skill sets I said. For these first type, this is the first type. What you want to do is simply do long division from beginning algebra. Okay, or you might have had some techniques in pre-calculus to do long division. What am I thinking of in pre-calculus? Do you guys, anybody remember that pre-calculus? What is it called? There's a technique. We even teach it in college algebra. Do you guys know what that is? It's what do I call it? You guys remember synthetic division? Yeah, synthetic division also, it's based on arithmetic. Now, I don't think in this section they want you to use synthetic division though. In this section, they only want you to use tools from beginning algebra. Long division, what I just showed you guys. You know, that's what they want you to do. So you're not going to be doing synthetic division. You're going to be simply doing beginning algebra division, long division. Remember what I said to you guys, this course is kind of the interesting thing. This course is 90% what you've had in the past. And, you know, it's a past kind of thing. So if you said, what did I show you that was new? All I showed you that was new, I think, in my opinion, right, is simply just use long division. That was it. You know what I'm saying? That's all that I showed you guys that's new, because this portion is calculus 1, and then calculus 2, well, yeah, we did talk about that from chapter 7, how to integrate, you know, 1 over x minus 3 or 1 over u. We did talk about that. So it's kind of calculus 1 and beginning algebra, really. So it's kind of, again, it's 90% of the past. And I bring that up too because you might say, you're talking a partial fraction decomposition, right? So you might say, well, what in the world is partial fraction decomposition, right? And if I give you guys an example here of what I'm talking about, just to kind of start here, just kind of a quick example here. 1 over, so I have here in my notes, I have a bunch of notes on this stuff. You have to integrate 1 over, for example. All right, I'll give you guys something. X squared plus x minus 2 dx. Okay? Now let me link what we are talking about today with what we're talking about now, because there's a link here. What do we see today? What was this called here today? You guys know what I'm saying? Yeah, that's a quadratic. So if you said to me, hey, Mr. Judge, I would rather do the techniques we talked about earlier. I would rather complete the square. Do you guys know what I'm saying? And use trig what? Substitution. And the answer is, for this example, you probably could do that. But what's going to happen in our future is, remember, in general, they can give you, you know, something a little bit more sophisticated. They can say, okay, we want to put here maybe a 3x minus 4 as a numerator. Okay, they can start to do those things. And the problem with that is completing the square and trig sub starts to become a lot more cumbersome, as you guys can see some of the examples we've done. You guys see what I'm saying? So even if you said, you know what, Mr. Judge, I don't want to learn anything new because, you know, it's new and sometimes there's resistance, but the irony, it's not new, it's your past, right? So you're entering in the world where you're transitioning from the complete the square and trig sub to, you know, other integrals that you're going to use another technique because that's a little bit more powerful for everything you're going to see now. I don't know if I'm making sense to you guys. So you say, well, how do we do that? Well, Anybody remember what is the purpose of partial fraction decomposition? I'm going to say this: use partial fraction decomposition. I call that PFD. Right? What's the real purpose of that? Do you guys know what the purpose of partial fraction? Maybe let's spell it out. Right? Partial what? Fraction decomposition. So see if you guys just remember the purpose of partial fraction decomposition. You know what you want to think of if it comes up later? Partial fraction decomposition is simply this. You take a rational function, r of x, and you write it as a sum or difference of quote unquote simpler what? Rational functions. That's what partial fraction decomposition is. So you're going to take this function here, 1 over x squared plus x minus 2. You want to write it as what? A sum or difference of simpler rational functions. Okay? You guys know what I'm saying? Here's my point to you guys. I want you guys to notice this. No, here's the complete idea. You're going to take the original 1 over, it was x squared plus x minus 2 dx. That's going to equal, I'm going to show you what it equals. An integral of 1/3, put it down here, 1/3 x minus 1 dx minus 1/3, minus 1/3 x plus 2 dx. And let me do this. Let me get rid of this. So you guys can see the point here. So appreciate what I'm saying. Here's the original rational function. And then what do you guys notice? That function is equivalent to what? A sum of what we say two simpler what? Rational functions. Okay, so you might have said, how do we go from here, the blue, to the other colors? This is what I'm saying. Use partial fraction what? Decomposition. That's the whole idea. Right, so that's the whole idea. Now, you might say, why is that easier? Well, pull out the constant. This now is 1/3 the integral of 1 over x minus 1 dx plus 1/3 the integral of 1 over x plus 2 dx. Integral, what's this? Integral. U sub, is that right? U sub, this is natural log absolute value x minus 1, natural log absolute value x plus 2, okay? So the final answer, you get 1/3 natural log absolute value of x plus 1 plus 1/3 natural log absolute value of x plus 2. And I think it's minus, and I apologize. That's a minus. And if you look in back of the book now, you might say, what is this going to be? Well, you got natural, you're going to factor out the 1/3. Natural log absolute value x minus 1 minus natural log absolute value x plus 2. Natural log of a difference, x minus 1 over x plus 2. And ladies and gentlemen, and there is a plus c, yes. Put your plus c at the end, okay? So in back of the book, you're going to see this answer. And you might start to say, well, why am I going to see that answer, right? Because to go from this step to the simpler, right? You got a rational function here. This is r of x. This is the original rational function. You write it as the sum or difference of simpler what? Rational functions. And that's the deal. But if you guys remember partial fraction decomposition, there's cases to look at. There's a process. You have cases here. So, I want to introduce that to you guys here because this is what we're going to look at and do, partial fraction decomposition. So that's actually, if we look at the book here, I did give you guys some homework on trig substitution. Is that right? I think I did, right? So here's what I want to say. This is 8.4. If you guys need to review partial fraction decomposition, I think it has some there. I want you to read that to review it, or you can even review it from an old pre-calculus book you may have. Maybe math, I don't know what you guys took, pre-calculus, or what do they call that? Math analysis. They used to call it math analysis back in the day. I think high school, does high school still call it math analysis? What do they call it, pre-calculus? Is it pre-calculus / trigonometry? Yeah. Yeah, they used to call it math analysis when I was a kid. I don't know what the difference is, but that's kind of where you're headed. So if you have to review partial fraction decomposition, review it because, it's a big deal. And there's another process and technique. So like I said, this course is really a course that's designed to, to go back and review some of these ideas. So even if you said, oh, Mr. Judge, I have to review, well, that's kind of normal. And get used to it because as you proceed with all the other courses you guys take, because this is kind of considered either a freshman, junior level, freshman, sophomore level math setting in some ways. As you proceed to the junior and senior level courses, what do you think you're going to be doing anyway? You guys are going to be doing reviewing. This is kind of how it works. So you'll review anyway. You'll be reviewing like Calculus 1 and Calculus 2. And it depends on what your major is, right? It really depends. So you will be doing some reviewing your whole academic career. So don't look at it in a way that's like you think, oh, this is hurting me. In all honesty, it's actually preparing you for the future because this is normal, having to go back and review and think about that. So, that's the best advice I have for you guys on it. I didn't look at it that way. I looked at it like, oh, I'm going to have to review this stuff. And I did. And, a lot of students have been successful doing this in Calculus 2 in my past. And you guys can be too, right? But, didn't know what people were doing in those pandemic and those online courses. If you guys know what I mean. Did not do. I suspect. Not here. So, you don't want to dig yourself in such a deep hole. It's hard to get out. You guys know what I mean? Anyway, I hope you guys enjoyed the lecture today. I hope you guys learned something. I hope you guys can do more of these questions in this last section, and we'll see you guys later. You have a wonderful weekend, and I'm going to work on that volume thing for you guys like I promised you guys. You know what I mean? The volume. I'm going to do that Calculus 2 volume-ish kind of questions. So I'll start to do that for you as well. So take care. We'll see you guys later.